In this video, I'll introduce the concepts that deal with temperature and heat. So this corresponds to Walker chapter 16. So first, temperature. Temperature has two different SI units. Either one is fine. So Kelvin or degrees Celsius. We all have a pretty good concept, we think, of what temperature is, but it's actually pretty hard to define. It's related to the speed at which the tiny particles of a material are moving. So if it's a liquid or a gas, you can easily imagine these, so that the temperature of the air that I'm standing in is related to the average speed of all of the air molecules. If it's water, it's the same way. If it's a solid, it's actually related to the vibrations of the solid. So that's what temperature is. Heat is easier to define, really. Heat is an energy, it's joules. So heat is just thermal energy. So we've already experienced some thermal energy. We've seen thermal energy created, for example, by friction. So now we'll see how thermal energy that's created changes the temperature of something. Thermal equilibrium. Thermal equilibrium is when there is no transfer of heat from one material to another, one object to another. Thermal equilibrium is also when two objects are at the same temperature. These mean the same thing. If two objects are brought into contact with each other and they had the same initial temperatures, then there will be no heat that transfers back and forth. If there is a difference in temperatures, then heat will transfer until they reach the same temperature. That's the 0th law of thermodynamics. Specific heat. This tells you the amount of heat that's needed to change the temperature of something. So if you put in a certain amount of joules, then a certain amount of mass will change by a given temperature. So that's what specific heat is. We will look at 3 different methods of heat transfer, but only conceptually. We're not going to do the mathematics that's associated with any of these. So the 3 types of transfer, one is thermal conduction. That's when two objects are physically touching, and they can be solids, liquids, or gas, and the material itself doesn't move. So that's the example that I just gave. If you have two solid objects, you put them next to each other, and they're different temperatures, then heat will transfer from one to the other through that direct contact. There is also heat transfer by conduction. This is in a liquid or gas only. Solid does not transfer heat by convection. It's related to the density changes and gravity. So if, for example, I have a fire here, then it heats the air, and you know what happens, the smoke goes up, right? When you increase the temperature of a fluid, it becomes less dense, so it expands. If it's less dense, now it's going to rise through the cooler fluid that's around it. So that creates convection currents. Okay? If I put a heat source here, then the air in this room will move up and then come around and circulate that way. So it's constantly bringing the cooler air to where the heat was. So that's a way of heat transfer in a fluid. It's actually the fluid itself that moves because of the density changes. There's also heat transfer by radiation. Radiation can move through vacuum. So this is light. Okay? For instance, the sun. The sun generates heat where it's at. It creates light energy that comes to the earth, and it's that light from the sun that warms the earth. So it's heat transfer by light energy. It can pass through solids and liquids, but it doesn't require any material. So if you think of yourself being inside your house in front of an open window, if the sun's shining on you, you can probably still feel the heat from the sun. Right? So it is passing through the air, it's passing through the solid window, so it can pass through these materials, but it doesn't require material to travel.